So before you watch this video, I'd actually like you to fill out your table of values in your notes. So in your table of values, what you're going to want to do is put in a whole bunch of different x's, all the way from negative 360 up to positive 360, and see what y values you get, and then try graphing it. And in this video, I'm going to show you what that graph should look like. So hopefully you've done that. I would recommend on your graph putting 1 up here and negative 1 down here, because those are the highest values and lowest values you'll reach. So it doesn't really make sense to put a 1 here. All right. You would have gotten 0 at these points. So when x equals negative 360, negative 180, 0, positive 180, and 360. You also would have gotten 1 when x equals 90, negative 1 when x equals 270, negative 1 when x is negative 90, positive 1 when x is negative 270. When x is 30 degrees, you would have gotten a half. You would have gotten root 3 over 2, or around 0.866, so kind of up here, when x equals 60. And your points should look sort of like this here. I'll connect those with a nice curved line here. And then you want to fill in all your points on the negative side as well. So also use your table of values for this. And that is what your sine function should look like. So this is what a graph of the function y equals sine x looks like. It starts at 0 at the origin, goes up to 1, comes back to 0, down to negative 1, and back to 0 again. So this is the graph y equals sine x. You want to be really familiar with what this graph looks like. We're going to be transforming this graph and doing all kinds of things with it in the rest of this unit. Right, so just a few fun facts about that graph. I'll just sketch it on the side here so we kind of remember what it looks like. Goes like this. There we go. The period of the sine function. So this is y equals sine x. No transformations to it, right? Just like the basic y equals sine x function. The period of this function is 360 degrees, right? From here to here is one whole cycle, and that happened in 360 degrees. The amplitude, if you notice, the highest value it ever reached was 1, and the lowest value was negative 1. So the amplitude is the distance from the middle line, which is right here, up to the highest point, and that distance is 1. So the amplitude is just 1. Where did that maximum point actually happen? Right, well, that maximum point is here. There's also another maximum here, and in fact, maximums just keep on repeating. If we draw this graph further, it keeps following the same pattern. But that first one happened at 90 degrees for x, and the y value was 1. For a minimum point, those happened here and here. So there's also another maximum point over here too. So I could write that one down as well. At negative 270 and 1. We also have a maximum there, and there's many more. All right, so our minimum points here, there's one over here at positive 270, and we reach the minimum value of negative 1. There's another one over here too, at negative 90 and negative 1. For the domain, well, the domain is like which x values are allowed, and this function just keeps on going forever and ever, right? Like it doesn't stop. So that means that any x value is allowed. X is an element of all real numbers. That's going to be your domain there. It just keeps going. The range is limited though. So the range, we'll start with y as an element of all reals. But you can see that the y values have to stay between negative 1 and positive 1. It doesn't get beyond that. So that's our restriction there. So less than or equal to negative 1 and up to positive 1. Where were those x-intercepts? So here's an x-intercept here, and here, and here, and here, and here. So they happened at the origin, there was one. There's another one that came up at 180. Y was 0 there. There's another one at 360. There was another one at negative 180 here, right over there. and another one at negative 360, and these keep on repeating themselves too as the graph goes on, right? So there's lots and lots more of those. Another thing to know about a sine function is it has what's called odd symmetry. So odd symmetry means that you can rotate your function around the origin. So if you put your finger here on your page, right at the origin, and then you rotate your picture completely upside down, so just like 180 degrees, you'll notice the sine function looks exactly the same. It hasn't changed at all. So that is what odd symmetry means, is if you can rotate your function 180 degrees and it still looks identical, then you have an oddly symmetric function. The sine function does that, so that means it has odd symmetry. Algebraically, another way to describe odd symmetry is that if you plug in a negative x value or negative theta value, if we're talking about angles, into your function, and then you plug in the same x value or same theta into your function, then what you'll notice is that the positive theta value will give you the opposite sign of the negative theta value. So let's see what this looks like. If I plug in sine of negative 30, that gives me negative a half, right? That's right here. So that's sine of negative 30. That's at a point negative 1/2. If I plug in sine of 30, that gives me positive a half. So that's right up here. That is positive 0.5. So this is just algebraically what odd symmetry looks like. You can see that sine of negative 30 is equal to negative of the sine of 30. So just a fun fact about sine functions. All right, at this point, you're going to want to pause the video again and fill in your table of values for the cos function. We're going to do exactly the same thing with the cos function and try and create your own graph, and then I will show you what it looks like. So pause the video, do that first. So hopefully your graph looks like this. You should put 1 here on the y-axis and negative 1 down here. You'll notice the cos function actually starts at 1. You would have had x-intercepts here at 90, 270, and goes back to 1 by 360 degrees. It's down to negative 1 in here. This will be 0, negative 180, you would get negative 1. Negative 270, you should have gotten 0. Negative 360, you would have gotten 1. Putting in a few more points, you would have had a half here. Root 3 over 2 around 0.866 there. Negative a half here. Negative root 3 over 2 there. So something kind of like this is what your table of values should be telling you. When we connect those dots, we get a function that looks kind of like this. And that is a cosine function. So that is the function y equals cos of x. All right, I'll just sketch it again on the side here so we've kind of got it nearby. It's one that you want to be really familiar with as well. There it is. That's cos function. Just the base cos function. The period of this, notice, is actually the same as last time. That's 360 there. Here's a full cycle down, up, and back. So the period is also 360 for a cos function as well as a sine function. And the amplitude, if I sketch a middle line on here, here's the midline. The amplitude is the distance to the highest point, and that highest point was 1. So this is when the midline to the highest point is 1, so the amplitude is 1. The maximum points happen here, and here, and here. So there's one at x equals 0, y equals 1. Also at negative 360, y is equal to 1 there. And there's another one over at positive 360, y is equal to 1. And this pattern keeps going, so the maximums keep going too. The minimum points are here and here. So they happened at negative 180 and negative 1. And also over here at positive 180, you get down to negative 1 as well. So those are your minimum points. And the domain is very much like the sine function, right? This will keep on going forever and ever. So that means that x is an element of all real numbers. And for the range, y is also an element of all real numbers, but y is trapped in between -1 down here and +1 up here. So the same restriction applies as did for sine of x. Lastly, there's our x-intercepts. So notice there's x-intercepts here and here and here and here. And they're happening at 90, 0 of course for y. This one's at 270. There's more at -90, -270, and they keep going, of course, off our graph as well. All right, the last thing to know about cosine function is that it has what's called even symmetry. So even symmetry means that if you put a mirror right along your y-axis, then you can reflect your function in the y-axis and it will look exactly the same on either side. So any function that, if you do a reflection in the y-axis and it looks identical, that's a function with even symmetry. And that's true for cos of x. Algebraically, that means that if you plug in a negative x value into your function, you'll actually get the exact same y value as if you plugged in a positive x value. So let's say we plugged in like cos of -60. Well, that would give you positive 0.5, right? And that's actually right here. But if you plug in cos of positive 60, you'll also get positive 0.5. Because of this reflection thing, you'll get the exact same y value. So that's another piece of even symmetry.